Case study: implementing AI-based intrusion detection systems, a case study of Technova's cybersecurity overhaul. Intrusion detection systems that use artificial intelligence represent the future of cybersecurity, offering sophisticated solutions to detect and counteract unauthorized network access and malicious activities. At the heart of these systems are machine learning algorithms, which can identify patterns and make decisions with minimal human input. Consider the scenario of Technova, a mid-sized technology firm specializing in cloud services and IoT solutions. The company has been expanding rapidly, and with growth, its cybersecurity concerns have multiplied. Technova's IT director, Laura, has been tasked with overhauling the company's security infrastructure. One critical component she plans to integrate is an AI-based IDS to protect the burgeoning network infrastructure. Laura's team begins by exploring various machine learning models to determine which would best suit their needs. They start with supervised learning, where the system is trained on a pre-labeled dataset. This model is straightforward yet powerful because it allows the system to understand the relationship between input data and corresponding labels. For example, the team employs support vector machines to classify network traffic as either normal or malicious. But what challenges might Technova face with a supervised learning approach? One major challenge is the availability of labeled data. In a real-world setting, obtaining a comprehensive and accurately labeled dataset can be arduous. How should Technova address the issue of labeled data scarcity? The solution could involve leveraging simulated attack data alongside real-world traffic data to create a more diversified training set. Additionally, Laura considers using data augmentation techniques to artificially expand the volume of labeled data, thereby enhancing the model's learning capability. Next, the team delves into unsupervised learning models due to their ability to detect anomalies without needing labeled data. They experiment with clustering algorithms like k-means and dbScan to group similar data points and flag outliers. Given the dynamic nature of Technova's network, which unsupervised learning model would be more adept at handling real-time changes? The answer lies in the adaptability of the chosen model. dbScan, for instance, is particularly effective at identifying clusters of varying shapes and densities, making it suitable for Technova's diverse data environment. However, the team must also set adequate parameters to balance the false positive rate with detection accuracy. Fine-tuning these parameters is essential to minimize false alarms while maintaining high detection rates. Reinforcement learning offers a different paradigm by allowing the IDS to evolve through interactions with its environment. Inspired by behavioral psychology, this model learns by receiving feedback in the form of rewards or penalties. What are the potential benefits and drawbacks of using reinforcement learning in an IDS? The primary advantage is the model's ability to adapt to new and evolving threats by continuously refining its policies. For instance, a reinforcement learning agent can dynamically adjust firewall rules based on detected intrusions, thereby optimizing defensive measures over time. However, a potential drawback is the model's complexity and the significant computational resources required. Laura's team needs to ensure that their computational infrastructure can support such an advanced learning system without compromising performance. Deep learning, a subset of machine learning, also presents promising opportunities for IDS. Laura's team investigates the application of convolutional neural networks and recurrent neural networks. CNNs excel at processing grid-like data structures, making them ideal for analyzing network traffic logs. Conversely, RNNs are well suited for sequential data, such as user behavior logs, capturing temporal dependencies effectively. How should Technova decide which deep learning model to implement? The decision hinges on the specific types of data and security challenges Technova faces. If the primary concern is detecting patterns within network traffic logs, CNNs may be the optimal choice due to their ability to extract hierarchical features. On the other hand, if understanding and predicting sequential user behaviors are more critical, RNNs would provide better performance. The team also explores hybrid approaches that combine multiple machine learning techniques. A hybrid model might use supervised learning to label data points and unsupervised learning to detect anomalies within the labeled data. This combination leverages the strengths of both techniques, enhancing the system's ability to detect known and unknown threats. For example, the team could use a CNN for feature extraction and an RNN for anomaly detection, thereby optimizing both spatial and temporal data analysis. Evaluating the effectiveness of these models is crucial for Technova. Laura's team uses metrics such as detection rate, false positive rate, and precision to assess performance. A high detection rate indicates the system's ability to identify intrusions accurately, while a low false positive rate minimizes unnecessary alerts. Why are these metrics significant, and how should the team balance them? Balancing these metrics is essential to ensure a robust and reliable IDS. A high detection rate coupled with a low false positive rate indicates a well-tuned model that can distinguish between normal and malicious activities without overwhelming security analysts with false alarms. Precision, which measures the proportion of true positive detections among all positive detections, provides additional insight into the system's reliability. Laura's team must iteratively fine-tune the model parameters to achieve an optimal balance between these metrics. Technova's real-world implementation of AI-based IDS highlights several practical considerations. The DARPA Intrusion Detection Evaluation dataset proves invaluable for benchmarking their models. Studies leveraging this dataset have demonstrated the superiority of AI-based approaches over traditional signature-based methods. With continuous cybersecurity threats, integrating AI-based IDS with other measures such as threat intelligence platforms and SIEM systems offers a comprehensive defense strategy for Technova. Despite the advantages, several challenges warrant attention. The quality and diversity of training data remain a pressing concern. AI models rely heavily on the data used for training, and biased or incomplete datasets can lead to poor performance. How can Technova ensure the availability of high-quality, representative training data? Ensuring data quality involves incorporating diverse data sources and continuously updating the dataset to reflect the latest threat landscape. Laura's team should collaborate with external threat intelligence providers and engage in data sharing initiatives to enrich their training data pool. Moreover, they should employ techniques like cross-validation to assess and enhance the model's generalizability. Another challenge is the interpretability of AI models. Deep learning models, despite their accuracy, often operate as black boxes, making it difficult for analysts to understand their decision-making processes. What steps can Technova take to improve the interpretability of their AI-based IDS? Developing explainable AI techniques is crucial. Laura's team can incorporate methods like LIME or SHAPE to provide insights into the model's reasoning. These techniques help demystify the model's decisions, allowing analysts to trust and act upon its outputs confidently. Scalability and performance are additional concerns when deploying AI-based IDS in real-world environments. Technova's systems must operate efficiently in high-volume network environments without compromising on responsiveness. How can the team optimize the efficiency of AI algorithms to meet these demands? Leveraging distributed computing resources and optimizing the computational efficiency of AI algorithms are key strategies. Laura's team should explore parallel processing and cloud-based solutions to distribute the computational load effectively. Additionally, implementing lightweight models for initial filtering, followed by more complex analyses, can help balance efficiency with accuracy. In summary, AI-based intrusion detection systems offer a robust solution for modern cybersecurity challenges. By leveraging supervised learning, unsupervised learning, reinforcement learning, deep learning, and hybrid approaches, Technova can develop a comprehensive IDS tailored to their specific needs. Evaluating these models using relevant performance metrics and addressing challenges related to data quality, interpretability, and scalability are essential for successful deployment. As cyber threats continue to evolve, integrating AI-based IDS with broader cybersecurity strategies will be pivotal in safeguarding digital assets and maintaining information system integrity.